Hello guys and welcome back to another video tutorial series on technical interview, and today we will be solving the problems of dynamic programming. So dynamic programming is considered as one of the toughest questions for technical interview. But believe me, you can easily solve the problems on dynamic programming if you are just familiar with few of the patterns of solving this type of problems. So during technical interview, a dynamic programming can easily be solved by using 5 to 6 type of approaches of solving this type of problem. And over here we will be covering all the patterns or the way of solving the dynamic programming so that it will be easy for you to solve the problem during your interview. So over here today we will be solving our first pattern, and that is the palindrome pattern. And the question that we will be solving today is the longest palindrome subsequence. So before solving the problem using the dynamic approach, we have to first understand the problem and we have to understand the pattern by which we will be solving the problem. So let's jump into the solution of solving the problem of finding the longest palindromic subsequence. And one more thing, if you are new to dynamic programming, do not skip this video and watch this video till the end, because in between I will be giving you some essential tips that will help you to solve any dynamic programming. So do not skip the video and watch through the entire video and try to understand each and every step that I am doing over here for solving the problem in the dynamic approach. So let's start with today's video of solving the longest palindrome subsequence. But before that, don't forget to like and share this video, and if you are new to my channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's start with the solution of longest palindromic subsequence. So before jumping into the solution of longest palindromic subsequence, let's first understand the problem. So the problem statement tells that given a string over here, we have to find out the longest palindromic subsequence. So first thing first, let's understand what is a subsequence and what is the difference between a subsequence and a substring. So a substring is basically a part of the string that are contiguous in nature. So over here, DD, will be a substring, whereas CPD will be a subsequence. So a subsequence can be a part of the string, but it is not necessary that the character will be consecutive to each other. So that is the difference between a subsequence and a substring. So in our next video, we will be solving the longest palindromic substring. But in this video, we will be solving the problem of longest palindromic subsequence. So over here, given a string abdbca, we have to find out a subsequent which is palindromic in nature, and we have to find out the subsequence having the maximum length. So over here, if you break this string into different subsequence, you can find out that over here A is a subsequence, similarly B, D, all these are individual subsequence, and also these are palindromic in nature since this is a one character in length, but the size of this is 1. Similarly, if you find out over here B, D and A, that is taking this string, is also a subsequence, and this is also palindromic in nature, but the size of this string is 3. So in this way, we have to find out all the possible subsequence that are palindromic in nature, and we have to find out the length of the maximum subsequence that can be possible over here. So over here you can see that ABD and BA is a subsequence, and this is palindromic in nature. So this is basically the problem statement that we have to solve over here. So obviously you can solve this problem using the brute force approach, but over here we won't be dealing with the brute force approach, rather we will be focusing more on solving this problem using the dynamic programming. So let's deep dive into this problem and let's understand that how we are solving this problem using the dynamic programming. So given the string over here, what we will be doing is we will be start our iteration from the last index of our string. So if you want, you can also start from the first. So it is according to your choice. But over here, what we will be doing, we will start our iteration from the last index of our string. And for the very first time of our iteration, we will be finding all the necessary subsequence having the length of 1, which are palindromic in nature. So over here, if you see, we will start our iteration from the last index of our string. So at the first time, it is A. So A is a palindrome and the length of this subsequence is 1. Similarly, we will move to the next index over here, that is C, which is also a palindrome as well as a subsequence in this string, and the length of this string is also 1. In this way, we will keep on iterating over here. Since now we have covered all the strings of length 1, now we will consider all the strings of length 2. Now at this point, since the length of the subsequent is 2 that we are checking over here, so we will be considering 2 strings at a time. So for the first time, since we are starting from the end of the string, the subsequence that we will be considering is CA, which is of size 2. So the first thing that we will be checking within this subsequence is whether this corresponding string is palindrome or not. So the necessary condition of being a palindrome is from the both side of the string it should be same. So over here also we will be comparing the first and the last string over here. Now since the 2 character of this substring doesn't match, so this string doesn't qualify the check of being a palindrome. So we will move forward to our next string, that is B and C. So over here similarly we will be checking this 2 string, that is the last and the first one, that is B and C. And over here also this corresponding string is also not passing the validation for being a palindromic in nature. So we will pass to the next string, that is D and B. And in this way we will be keep checking the 2 characters at a time. So on this iteration where the length is 2, we have checked that none of the substring that we have validated till now with length 2 has passed our check of being a palindrome. So none of the substring of length 2 is a palindrome. So until now the maximum length of the substring that we have encountered is 1. Now we will start our iteration again with length equal to 3. And now we will be checking 3 characters over here, that is B, C and A. And similarly over here to check that whether this corresponding substring, that is BCA, is a palindrome or not, we will be comparing the last and the first characters of this string. So over here also the last and the first character of this string doesn't match, so this is not a palindrome. And since this is not a palindrome, the longest palindromic subsequence of this string will be either the max of BC or CA. So the formula is very simple. For a particular string, we will check that whether the first and the last character matches or not. So if it doesn't match, means it is not a palindrome. And if it is not a palindrome, then we will check the maximum length of the palindrome that could be formed by taking these 2 strings. So over here you can see that the maximum length of the palindrome of size BC means this string was 1. So over here it was 1, and also for CA it was 1. So the maximum size of the palindrome that can be formed using the string BCA is max of BC and CA. So over here the value is 1. So the length of the maximum palindromic subsequence using this string is 1. So I hope this explanation is clear to you. So now we will iterate forward and we will take the next string, that is DBC. So over here also in the string DBC, the first and the last character doesn't match. That means this is not a palindrome. And so the maximum palindromic subsequence size will be the max of DB or BC. So over here the size of the DB was 1, and similarly the size of CB was 1. So the maximum palindromic size of DBC is also 1. And in this way we will keep iterating. The next string that we will be encountering is BDB. And for this string DBD, you can see that the first and the last character of the string matches, and thus this is a valid palindrome. And since this is a valid palindrome, the length of this corresponding subsequence will be 2, which includes this character and this character, plus the maximum length of the palindrome that is lying in between, that is D, that is of length 1. So the total length of the palindrome will be 3. So over here you can see we got a new palindrome subsequence of size 3. Now we will again move forward with our next string, that is ABD. So over here also in ABD, the 2 character doesn't match, and thus the length of this palindrome will be the max of AB and BD. And the length of AB and BD was 1 and 1. So the maximum length of this will be 1. So I hope you guys are clear with how we are dealing with each and individual item over here. Now we will move forward with our next iteration of string of length 4. Now in this case we will be taking strings of size 4. So over here we are getting the string DBCA, and here also we will be checking that whether this string is a palindrome or not, and for that we will be checking the first and the last character over here. So this is not a palindrome, and thus the maximum palindromic size will be the max of DBC or BCA. So over here you can see that the maximum size of DBC, that is this one, was 1, and BCA, that is this one, was also 1. So the maximum length of the palindrome over here is 1. So over here, if you notice one thing, you can see that we are using the pre-computed value over here. So over here you can see that dbc was a string which was pre-calculated, and we are using the corresponding value of that length to find out the further solution. And this is the reason we need to store this answer in a table which is known as a memorization table. And with the help of the memorization table, we normally solve the problems of dynamic programming. Because you can see that for solving each and every solution, we need the answer of our previous solution. So we need to memorize the answer of a current state so that we can use those answer in the upcoming state. And that is why we will be solving this type of problem using the help of a memorization table. So how to construct that memorization table, we will be seeing later. Let's first manually solve this problem. So over here also, the length of this string of length 4 is 1. And now we'll go to the next iteration, that is, we'll take the next string, that is bdbc. So over here in this string, you can see that in the bdbc, this two string is not matching. So this is not a palindrome. So we need to compute the maximum of bdb and dbc. So you have seen that the length of bdb was 2 and here the dbc was 1. Hence the maximum length of this subsequence is 2. Again we will check with the next one, and that is abdb. And in this way we will keep on checking each and every string over here and we will compute the maximum substring problem. So after we are done with this computation, we will increase our length of the string to 5, and over here also we will be computing with the string bdbca of length 5. So over here you can see that bdbca is not a palindrome, hence the maximum size of the subsequent will be the max size of this or this. So in this way we will keep on computing each and every iteration to find out the maximum solution. So at the end of the total iteration, when we will reach the length equal to 6, you will see that the value of the maximum substring will be equal to 5, which is our desired answer. So this was basically the code logic or the basic process by which we need to solve this problem. So over here you can see that for each and every subsequence that we are getting, we are computing the longest palindromic subsequence for that given string, and we are storing that value in some fashion so that we can use those values in our further step to find out the longest palindromic subsequence. So this process is known as the bottom-up approach. Since over here we are solving the minute or the smallest problem first, and then we are merging that problem with the next problem, and in this way we are finding the final answer, and that is why it is known as the bottom-up approach. So normally there are two types of approaches for solving the dynamic programming. One is the top-down approach and the second is the bottom-up approach. So I normally prefer to solve the dynamic programming using the bottom-up approaches, because using the bottom-up approaches you need to solve the small problem first and then you have to build the problem so that you can get your desired solution. And this can be easily done using a memorization table. And I personally feel that finding the solution of dynamic programming using the bottom-up approach is much more easier than that of the top-down approach. But that is totally my personal opinion. Now since we have got the idea of solving this problem using this approach, now we will be seeing that how the memorization table, which is the core concept of the bottom-up approach for dynamic programming, helps us to solve this problem in a much more simpler way. So let's start solving this problem using the bottom-up approach with the help of the memorization table. So I hope you guys have clearly understood the solution until now. If so, please do like and share this video, and if you are new to my channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's start solving this problem using the memorization table. So over here you can see that I have created a memorization table of size 6, which is the length of this complete string, so that we can store the computed value at each and every step so that it will be easy for us to find out the solution of the problem. So let's start with the solution. So just like the previous approach, here also we will start our iteration with the last index of our string, that is from here. And for the first time we will be taking all the substring of length 1. So over here if you see that the index of this substring is 5, 5, which is denoted by this index over here. And for the single character A, the longest possible subsequent is of length 1. So over here we will be updating this cell by the value of 1. Similarly, at the position over here, that is C, which is denoted by the coordinate as 4, 4, over here the longest possible subsequent will be also 1. So if you see that all the diagonal elements actually denote each and every individual item, and the longest possible subsequence that can be formed by a single element is obviously 1, and thus we will be initializing all the diagonal elements by 1. Now we will move forward with our iteration, and then we will take next possible string of length 2. Here also, just like our previous approach, this time we will be considering strings of size 2. So the first string that we will be considering is CA. So over here CA denotes the position 4 and 5. So over here you can see that the 4 is the starting coordinate and 5 is the ending coordinate, and the possible entry of CA on this memorization table is this position, where the value of start is 4 and the value of end is 5. So over here, as we have seen, that since this is not a palindrome, so we need to find out the max of C and A. So now what we are checking, that basically if this given string is not a palindrome, then we have to take the max of this two number, which is nothing but the max of C and A. So over here you can see that with the help of this memorization table, finding the value or the previous answer is quite easy over here. So over here you can see that the max of 1 and 1 is also 1. Similarly, we will take our next iteration, that is B and C. And over here, since this is also not a palindrome and we need to put our entry over here, that means that we have to find out the maximum of this and this, which means the maximum of B and the C. And the value of max of 1 and 1 is also 1. And in this way, we will keep on computing. Now since we are done with all the strings of length 2, now we will move forward with length 3. And the first string that we will be taking is B, C and A. And since the string BCA is not a palindrome, which means we have to take the max of BC and CA, which means for the string BCA, which is denoted by this cell, and since this is not a palindrome, we have to take the max of this or this. So over here the max of 1 and 1 is 1, and in this way we will keep on computing. So over here in this case, you can see the string is BDB and the string BDB is a palindrome, and thus what we need to do, our calculation will be 2 plus the length of the string in between that. And how to find the length of the string in between that is we will be pointing to the item over here. So for example, for the string BDB, actually we are pointing the location this in our cell. Since the starting index of B is 1 and the ending index of this B is 3. So basically we are pointing this cell over here. And since this is a palindrome, the value will be 2 plus the value of this cell, that is equal to 3. So I hope the way it is getting computed, it is quite clear. So let me write the general formula of how we are populating this above table. So if in a given string the first and the last character of the string matches, means this is a palindrome, and if this is a palindrome, then we will be populating this table by this mentioned formula, which is nothing but the cell over here. And if it is not a palindrome, then we have to calculate the max of this two cell. So using this basic formula, we need to populate each and every cell over here, and at the last we will get our desired solution over here, that is the last index of our cell. So let's populate this entire table by parsing this string over here. So over here you can see at the end of the complete iteration, the value of the longest palindromic subsequence is 5. So I hope you guys are clear with the approach by which we are forming this table, and you are also clear the reason why we are using this corresponding formula. Because in many of the videos and books I have seen that they have directly given this formula for solving the problem without explaining the each and every step why you need to build this formula to solve this problem. But over here I have explained in detail that why we are building this formula and why it is necessary to build this memorization table to get our desired solution. So I hope you guys are clear with the entire approach of solving this problem using the memorization table. Now let's write down the Java code to implement the solution. And believe me, writing the Java code to implement this DP algorithm is very simple since you guys have already understood the reason behind the implementation of this formula. So let's write the Java algorithm to solve this problem. But before that, if you like the video, please do like and share this video. And if you're new to my channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are ready for your next interview. So let's start writing the Java code for this solution. So let's name the function as Longest Palindromic Subsequence. So the first thing that we have to do is we have to initialize a memorization table of size equal to the length of the string. Now the next step is we need to fill up all the diagonal elements with the value of 1, since each character of a string is already a palindrome of size 1. So now we are done with the initial setup over here. Now we just need to compute the value of each and every cell, and we have to write the for loop to find out our given solution. So let's write the for loop so that we can get each and every substring over here. So this do for loop will generate all the possible substring that can be formed from the given string. So over here, the first thing that we will be checking that whether the string is palindrome or not. And if the string is a palindrome, then we will be populating the DP cell using this formula. Otherwise, we will be populating using this formula. So once over here, we have successfully populated the DP memorization table with the length value. Now the required answer will be on the last cell of our DP table. So let's return the answer over here. So I hope you guys have thoroughly understand the implementation of the longest palindromic subsequence using the dynamic programming. So if you have any doubt, please let me know in the comment section below. I will be happy to help you over there. And also I will be providing the same code in the description below. Feel free to go through that carefully so that you can easily understand the solution and you can easily crack the question during your interview. So if you have liked this video, please do like and share with your friends. And if you are new to my channel, please do subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's go to the next problem of our dynamic programming, and that is the longest palindromic substring, which also comes under the same pattern, that is our pattern 1, which is our palindromic pattern. So let's see you on the next video where we will be solving the longest palindromic substring. See you on the next video. Thank you.